Hello students, today is our fourth class of some basic concepts of chemistry. So let's start with law of chemical combinations. Law of chemical combination. Uh, In use to understand the composition of compounds or how elements are combined to form compounds. There are a few basic law. Actually, there are five laws on which they are based. First law is law of conservation of mass. Law of conservation of mass. Law of conservation of mass was proposed by Antoine Lavoisier, father of chemistry, in 1789. According to Antoine Lavoisier, matter can neither be created nor be destroyed. Matter can neither be created nor be destroyed. Or you can say the total mass of product, the total mass of products in the total mass of the product is same as the total mass of reactants in a chemical reaction. What it means, for example, if S2 react with O2, it gives S2O. Let's balance it. Here, mass of one H2 molecule is 2 gram and 2 2s are 4 gram. Mass of one molecule of oxygen is 32 gram. Here 2 into 2 plus 16. Mass of one mole of one atom of oxygen is 16. So 16 plus 2, 18. 18 2s are 36 gram. Here it's 32 plus 4, 36 gram. Mass of reactant is equal to mass of product. You can take any reaction, balanced reaction for the same. For it, reaction should be balanced. Second law is law of definite proportion. Law of definite proportion. Law of definite proportion, according to law of definite proportion, a given compound always contains exactly the same proportion of element by weight. Let's write it. A given compound always contains exactly the same proportion of elements by weight. It means, let's take our previous example. 2s2 plus O2 gives 2s2O. Here, mass of 2 mole of S2 molecule is 4 gram, and oxygen it's 32 gram, and water it's 36 gram. Here, according to law of definite proportion, which is proposed by Joseph Proust, uh, either it's a sample of water. If you take, let's take an example of water. If you take different samples of water from different sources like mineral water, Ganga water, tap water, then what do you find? That the same proportion of element by weight, means it is made by same proportion by weight. Hydrogen and oxygen combines in same ratio to form these all samples. Like here the ratio is 4 is to 32. 4 is to 32, and that is 2, 6, 1, 8. The ratio 4 by 32 is equal to 1 by 8. What it means? That hydrogen and oxygen combines to form water in 1 is to 8 ratio. This ratio is fixed for any source of water. Okay. Let's start our third law. Our third law is Gay-Lussac's law of gaseous volumes. Gay-Lussac's law of gaseous volumes. It is proposed by Gay-Lussac in 1808. According to this law, Gay-Lussac proposed that under similar condition of temperature and pressure, under similar condition of temperature and pressure, whenever gases combine, they do so in volume which bear simple whole number ratio with each other and also with gaseous product. What let's write its statement first. Under similar condition of temperature and pressure, under similar condition of temperature and pressure, whenever gases combine, they do so in volumes which bear simple whole number ratio with each other and also with the gaseous products. Let's take one example. Suppose H2 gas plus Cl2 gas. H2 gas plus Cl2 gas gives 2HCl gas. Here one volume of hydrogen combined with one volume of chlorine, and the product is 2 volume. Ratio is simple, 1:1:2. Suppose that we are taking 100 milliliter of hydrogen. Then if 100 milliliter means 1 volume, then for 1 volume it's also 100 ml. For 2 ml it's 2 into 100 ml, that is equal to 200 ml. Let's take one more example, that is nitrogen plus hydrogen gives ammonia. Here 1 volume of nitrogen combined with 3 volume of hydrogen to gives 2 volume of ammonia. Yeah, 1 volume of nitrogen combined with 3 volume of hydrogen to give 2 volume of ammonia. Suppose that we are taking 25 ml nitrogen molecule. If 25 ml is for one volume, then for 3 volume it's 25 into 3, that is equal to 75 ml. For 2 volume it's 25 into 2, it's 50 ml volume. Here the ratio of volume is 1 is to 1 is to 2. Here it's 1 is to 3 is to 2. That is a simple whole ratio. Okay. Our third law is, fourth law is law of multiple proportion. Law of multiple proportion is proposed by Dalton in 1803, right? It states that if two elements can combine to form more than two compounds, the masses of one element that combine with fixed mass of other element are in the ratio of small numbers. Okay, let's write it. If two elements can combine to form more than two compounds, if two elements can combine to form more than two compounds, the masses of one element that combine with a fixed mass of the other element are in the ratio of small whole numbers. Okay. For example, for example, 2 mole of hydrogen react with 1 mole of oxygen to gives 2 mole of water, right? And what it say, two elements can combine to form more than two compounds. Here two elements are hydrogen and oxygen. If hydrogen and oxygen combines to make more than one product, here hydrogen and oxygen combine to make water. Same again, hydrogen and oxygen combine to make H2O2, that is hydrogen peroxide. Here it's 4 gram, oxygen is 32 gram and water is 36 gram. Here it's 2 gram, 32 gram and it's 2 plus 32, that is 36, right? 32 plus 34 gram. Now according to law of multiple proportion, what it says, one element that combined with fixed mass of other element. If one of them is fixed, then the ratio of rest is in same ratio. Suppose that we are going to fix mass of hydrogen. Then here mass of hydrogen is 4 gram, 32 gram, it's 36 gram. Here mass of hydrogen is 2 gram. So what to do? It's 2 gram, 16 gram, and it's 18 gram divided by 2. Now mass of hydrogen is 2 gram, mass of oxygen is 16 gram, and mass of water is 18 gram. Here mass of hydrogen is 2 gram, mass of oxygen is 32 gram, and mass of water is 34 gram. Now if two elements combine to form more than two products, the first product is water and second product is hydrogen peroxide. Then what happen with a fixed mass of other element? Here mass of hydrogen is fixed 2 gram 2 gram. Then mass with the fixed mass of other element are in the ratio of whole number 16 by 32. 16 by 32, that is equal to 1:2, and 1:2 is a simple whole number. Okay. Let's discuss on our fifth law of basic law. Fifth one is called Avogadro law. Avogadro law was proposed by Avogadro in 1811. According to this law, Avogadro proposed that equal volume of gases at the same temperature and pressure should contain equal number of molecules. Suppose that we are taking three balloons having same volume. If its volume is V, same volume. One is filled with hydrogen, another oxygen, and third one is nitrogen. If volumes are same and at constant temperature and pressure, same temperature and pressure, if temperature and pressure of all three are same, is at same temperature and pressure, temperature and pressure is constant, volume is also fixed, then number of molecule in first balloon is equal to number of molecule in second balloon and number of molecule in third balloon. It means if volume is same, then it contains same number of molecule at constant temperature and pressure. That's all for today. Thank you. In our next class, we will start with Dalton's atomic theory, and thank you.